Hello everyone. We are pleased to present our final year Stage 2 project titled AI Supervision and Validation System using Computer Vision. I'm Samya and with me are Prajakta, Aditya and Vaibhav. Our project guide is Professor Pooja Barakar. Let's walk you through what we've built and why. This is a table of contents for our presentation. We will start with a quick introduction and background. Then we will move through literature survey, problem statement, objectives, and scope. We'll explain the system architecture and methodology, followed by implementation details, results, challenges, and finally, the conclusion and future scope of our project. Introduction. Our project addresses the need for validating manual tasks in real time. In many industries, like manufacturing or healthcare, validation is often manual, slow, and error prone. Especially after COVID 19, there's a great push towards touchless and automated systems. We were motivated by the real world potential of using AI and computer vision to solve this challenge, automating process supervision and validation for better accuracy and efficiency. Literature survey. We refer to multiple papers to understand how AI and computer vision are already being used in surgical and motion tracking applications. Some focused on AI-driven robotic surgeries, others on object tracking and image layering. These studies gave us insights into real-time object detection, accuracy enhancement, and system responsiveness, which inspired parts of our design. Research gaps. From our survey, we identified that most existing systems are resource heavy and not easily customizable. We wanted something that is lightweight, doesn't require large data sets, and works in real time with minimal hardware. By leveraging edge computing and multi-threading, we improved the system speed and parallelism, solving key performance gaps in traditional models. Problem statement. The main problem we are solving is the manual validation of tasks, which is time consuming and error prone. Human oversight can miss steps or allow incorrect sequences, leading to quality and safety issues. So, we built a low cost AI based system that uses computer vision to track tasks in real time and ensure they follow the correct sequence within defined regions of interest. Objectives. Our goals were 1. To build an intuitive interface to define ROIs and processes. 2. Using real time hand tracking to check task compliance. 3. Provide manual feedback, immediate feedback on mistakes. 4. Store process rules securely. 5. Reduce manpower dependency. 6. And finally, include a dashboard for monitoring and analytics. Scope of the project. Our system is meant for controlled environments like factories, training centers, or labs. It uses regular webcams and mid-range systems, making it cost-effective. It tracks hand movements, validates them against the task sequence, and can be extended for gesture automation or multi-user tracking. It's modular and scalable, perfect for SMEs and industry use cases. Methodology and system architecture. We followed a dual mode architecture. In admin mode, the user defines regions of interest and sets the correct sequence of actions. In user mode, The system tracks real-time hand movements and checks if steps are followed correctly. We use MediaPipe and OpenCV for vision tasks and integrated ML for posture estimation. This system gives live feedback if a mistake is detected and supports a dashboard for analytics and report. Implementation. The following slides show the actual working of our system. The admin screen allows users to draw ROIs and define sequences. In user mode, hand tracking is live and any deviation from the set sequence is immediately shown on the screen. We also implemented a dashboard to visualize validation results, errors, and task metrics, which can help management make informed decisions, which are data driven. Result and evaluation. We observed the following metrics. Accuracy of validation. Accuracy is correct cycles over total cycles. This indicates how often the system correctly validated a process cycle. Error rate. Error rate is incorrect cycles by total cycles. It measures the percentage of cycles flagged as incorrect for process violations or mistakes. Correctness ratio. Correctness ratio is correct cycles by incorrect cycles. Challenges faced. We faced a few challenges. Hand misalignment or rotation confused poor detection. When hands were partially hidden or moved very quickly, the system struggled. Conclusion. To summarize, we have built an AI-driven validation system that uses computer vision to track hand-based tasks and validate them live. The system reduces the need for constant manual supervision and can be adapted to various industry settings. With edge computing, we ensured fast local processing and the system can be integrated with dashboards or legacy software. Future work. For the future, we aim to add predictive analysis using deep learning, combine vision data with sensor inputs like temperature or pressure, improve performance in dynamic conditions like poor lighting, simplify the setup for wider industry adoption, extend applications to medical training, industrial automation, and skill assessments. We are happy to share that we have presented our work at the 2025 Global Conference on Cognitive Computing and Communication Technology organized by IEEE Pune section. Our paper focused on system design, implementation, and evaluation. A detailed video demo of the project is available and will be submitted as part of the final documentation. It showcases both admin and user modes in action. These are the key references that supported our research and implementation, from journals on computer vision and AI to robotics applications. Thank you for your time and attention.
Hi everyone, I am Vaibhav and today I'm going to give the demo of our hand tracking system, which is AI supervised. The demo is divided into three parts. The first is region of interest definition, the second is process definition, and the third is user mode, where basically we are verifying the cycle, whether it's correct or not. So let's dive into the first part of the demo. Okay, so what we are doing is here we are setting up the system by defining the regions of interest. In our case, we have three cans of Coke placed in a sequence at position 1, 2, and 3. which we will define later. We are using a webcam to mark these positions on the screen. The regions are visually represented, so we can later identify the exact areas where each object is placed. This step ensures that the system recognizes the specific position we want to monitor during the task. Let's start by defining the first position and then now saving it. Let me do the same for the second position. So, okay, same for the third. Okay, since now we have defined the regions of interest, let's move on to the second step, which is defining the process. Okay, so in this step, we specify the order in which the region should be accessed. For our demo, the case in positions 1 to 3 must be handled in a particular sequence. Uh, this sequence is critical as it allows the system to verify whether the correct ROI is accessed in the right order or not. Here we are programming the system to check whether the sequence of actions match the definition process or not. So let me add the steps. Since we have 3 cans, so let me add 3 steps as we. Now we have to define the process sequence, right? The first can goes to the position first, the second for the position 2, and the third for the position 3. Okay. Now we click on the save process button, which will basically save the sequence in which the hand should be tracked. Okay, so let's move to the final part of the demo where basically we are tracking the process sequence, whether the user is following the correct cycle or not. Let's click on the start user mode button. Okay, so we can clearly see the region of interest which we have defined. Let's try to execute the cycle. First of all, we pick the can and put it in the position 1. As we can see, it detects the hand that it goes to that specific region. Put the can, put it in position 2, and do the same for the third and the last can. As we can see, since we have correctly executed the cycle, so it displayed the message that the user executed the correct cycle. Okay, so since we have seen what happens when user executes the correct cycle, right? Now we will also, since we are tracking whether the user is following the sequence correctly or not, we're gonna execute a wrong cycle. So what we will do, we'll put the can in the position first, and then try to put the second can in the position 3, and third for the position 2. Since we can see that the user did not execute the correct cycle, so a message that the user executed the wrong cycle got displayed, and also the number of the incorrect cycle got increased. If we will execute the right cycle again, let's reset it. Okay, let me pick the can and put in position 1, then position 2, and then position 3. Since now user correct executed the correct cycle, the message got displayed, and also the number of the correct cycle uh, got increased. If we will do the same with this again, uh, pick it up, and then again the correct cycle executed message got displayed, and the number of the correct cycle also got increased. So this was our demo.